In 1991, the first ERS, or European Remote Sensing Satellite, was launched by ESA on top of an Ariane from Europe's spaceport in French Guiana. 4 years later, in April 1995, ERS-2 was launched. At the time of their launches, they were the most sophisticated Earth observer satellites ever built.
The main objective was to observe the oceans, and therefore we had instruments on board to measure the ocean temperature, for example, to measure different states of the sea via the radar, also during cloud cover or by night.
Not only ocean temperature could be measured by ERS. They were the first European satellites to carry SAR, synthetic aperture radar, which could be used to measure wind speed and direction, as well as wave height estimations. Additionally, they had a scatterometer, also mapping ocean winds, and an altimeter looking at the surface of the oceans and the ice shields of Antarctica and Greenland, producing the most accurate global measurements ever available. Even though both satellites were very similar, there was one huge difference between the two. ERS-2 had one new piece of equipment named GOME.
The instrument GOME, Global Ozone Monitoring Experiment, was a real first. It probed for the first time the gases which are created by mankind. We were able to measure pollution from space for the first time.
It was this set of unique instruments that provided the data for scientists to understand better the workings of the atmosphere and the oceans. But later came the surprise that both satellites were more than just ocean observers.
The ERS was a success because really it went much beyond expectation, and in that it was supposed to mostly study the sea surface, and it was a wonderful tool to study ground motion. Another application that is very important is studying the topography of the ground. And here we have many alternate possibilities, but SAR is precise. And so typically with using SAR interferometry we were able to have a global model of the Earth.
And so ERS became standard instruments for geosciences. And they kept regenerating data and sending it to ESA's Earth Observation Management Facility at Esrin in Italy. This continuous ERS observation of the Earth over the last 20 years has had a huge impact on our understanding of our Earth.
ERS-1 and ERS-2 and ENVISAT provided a very complete picture for us of the behavior of the oceans, and particularly those properties that affect the ocean's interaction with our atmosphere. And of course, it's the behavior of the atmosphere that we really feel every day in our weather.
As the Earth we live on is the most prized possession and asset for the human race, ESA looks to the future with its continuing Earth observation program. So even with the ERS satellites retired, their legacy will remain. New projects to observe our planet from space will gather enough data to produce long time series for climate research that will inspire future generations of scientists to help us better understand our planet home.